Hello everyone, welcome to my talk. Today I'll be speaking about harnessing the power of robot framework for the automation of data quality controls. My name is Rohit Ram. I work for the company Tata Consultancy Services, which is a global IT consulting firm. I'm a test automation architect and a data warehousing expert. I'm also an automation trainer and coach. Before getting on to the actual topic, let's spend a few seconds talking about data. Data occupies central field in almost every sector of IT. I've listed on a few based on my experience. In market research, we use data to measure a campaign's unique audience and impressions. In retail, we use data to measure the sales and also to estimate the future sales. In airline, we use data to fix the price elasticity based on the previous performance and also the current demand and supply. In banking, data is widely used in fraud detection, stock market analysis, and rating and scoring of customers. Data is also widely used in healthcare, manufacturing, and several other sectors. The live use case which you have selected for today's talk is a project that we helped a banking customer to automate the process of data validation. During the earlier phases of the project, the business users framed the SQL queries manually and executed them in the databases. They got the results, and based on the acceptance criteria, they validated whether the test cases have passed or failed. There were close to 500 to 700 separate different SQL queries, and business took around 5 to 7 weeks to automate for single delivery. We identified the pain point here and the amount of manual effort spent, and we proposed for the automation of this data quality controls, and we chose to call it monthly controls, since these are run every month. This is a high-level data architecture like any ETL program. This is not the original architecture of the project, but just a rough architecture for the talk purpose. The data comes in from several zones or several databases, let's call it, like SQL Server, Oracle, Teradata, or in case of flash files as well. Let's say flat files in the form of CSVs with a pipe delimiter or an XML file. All these data arrives at different parts of the day, and they land in the sourcing zone, which is hosted in Hadoop. The sourcing zone, each of the zones actually contains a lot of tables by itself. There's no transformation logic involved here, but just a lift and shift of data from source to the sourcing location. Once all the tables are loaded in the sourcing zones, then we run our application transformation jobs that transforms the data and populates the tables in the transformation databases. These are again classified as zones as per business requirements. Once all the transformation jobs are done, then we run the downstream delivery jobs that delivers the data as flat files to the downstream systems or as to the data mart, which is hosted in Oracle. Once again, the application jobs run in data mart zones. Then we deliver the data to the downstream systems. The automation tech stack. As I told, the application database resides in Hadoop and Oracle. The automation tool selected was Robot Framework with Python. And automation framework is a hybrid framework which combines page factory model combined with data and keyword driven approach. We use CI/CD tool Jenkins and Bitbucket as a code version control system. The environments are where these controls were run were test, dev, pre-production, and production, and it depends on the users who run the controls. Although it's originally built to serve the UAT and the modeling teams to run it in the production, during the course of time, it was expanded to the other systems as well. For example, the testing team runs it in the test environment for unit testing. The development team runs it in the development environment for sanity checks to see whether the code is not breaking any of the existing functionality, more like a regression kind. Then we have the IT analyst running this queries on the controls on the pre-production environment or the production environment to check the actual correctness of their particular feature. The development approach, which we choose, was a much stable one and a proven approach. We identified patterns out of the given problem statement. To dig deeper, so we took a case study from the business as to how many queries they are running for each of the modules. As I told earlier, there were around 700 queries, and we have to classify them into separate categories before we actually started our automation job. These queries had different patterns, different acceptance criteria, and also different sources and target systems. So once we identified this pattern, we classify the checks broadly into two categories. Category 1 check that had linear validation. That means it is run on a specific month or a period. And category 2 checks that's run on a variable time period, like more like a time series check. We started with a minimal test case as a POC, and we took null checks as a use case for category 1. That means we validate whether the table key columns have nulls or not, and then based on the acceptance criteria, we passed or failed the test cases. Once that was done, then we started with the use case for category 2 checks. It was more like a sum check, wherein we calculated the sum of a particular column and saw whether the variance from the previous months were falling within the threshold limits. Once we were able to successfully automate these two test cases, we extended the test cases or the approach to the several other test cases. Then we saw an opportunity to expand it to the business layers as well. So to give a background, we initially had the controls only at the transformation layer. So during the due course of time, we identified many of the checks were failing, and we have to reiterate the whole development or rerun the whole development jobs because the sourcing tables didn't have the corresponding data. So we found the opportunity wherein we need to run the controls in the sourcing layers as well. So then we expanded the solution to different business layers like sourcing and data mart layers as well. And our main motto was to keep the code simple but efficient. Simple for the reason that we believe that even a person who's new to the technology should be able to adopt and automate, and not only the key developers or pro Python developers. Again, efficient, we wanted to keep it for the reason that the application job runs for a longer time, provided the transformation logic and the data volume involved. So we have to run our controls in much quicker fashion without any time lag. Hence, we achieved a simple but efficient as a target, and we were able to sail through it. The main aspect which we were keeping on the mind right from day one is the scalability. That means while incremental development, we do not want to redevelop or reinvent things. We want to use the existing functionality and extend it to the different systems. The major components of a code, as we see it, are two major ones. One is the Python query generator Python file, and the second one is the test data file, which has data in the YAML format. Let me go a bit deep into the query generator part. So different category checks have different Python files, and each of the Python files you can find functions for the corresponding test cases. And it returns an SQL statement as an output of this query. And this is more like a base query, which has a for loop, and it loops through each of the columns or the tables and columns mentioned in the test data. Thus, by achieving the query that the business used to write it manually in the early phases. Similarly, we wrote the Python, we created the Python query generator for the category 2 checks as well. It was a bit more complex, provided the nature of the check, but we were able to achieve it. Moving on to the test case section, we used YAML for the reason that it was easily relatable to a Python collection. When I say a Python collection, you can visualize that the corresponding data in the test data file is nothing but a list of dictionaries. So each item in the list is nothing but the table name as a key, and column name as the list of values. And similarly, it loops through it. So we were able to successfully provide a much scalable framework with this, for the reason that Python file was untouched unless a major component change or a major functionality change was required. Parallelly, YAML files had a day-to-day change with test data flowing in, with new tables flowing in as well. So when a new table gets added, all we need to do is nothing but add a new element to the list. And there were several other test cases that follow different patterns, but we stuck to the motto that the structure of the test data always replicates a Python collection format. So it's easier for us to uh, read through the files, and we use the YAML extended libraries to read through the test data as well. So in this way, whenever a new business layer also gets added, we were able to expand the existing methodology, I would say. When we started the framework, it was a much linear one. That means there were not many customizations that were required. But in due course of time, we have to make the frameworks flexible to handle different needs. The first one is a prefix and suffix to the tables. When I say prefix, let's assume a database or a data warehouse where we have multiple code versioning. So code version 1 is deployed in the first 200 set of tables, and the code version 2 is deployed in the second 200 set of tables. Let's call this primary and the secondary tables. So primary tables has the original table name. It's called maybe customer details. But the secondary table, well, maybe it's residing in the same database on another database. But for identification, we have prefixed it with the prefix, let's say dry run underscore, and suffix, let's say today's date, February 28th. And that being said, if we give both prefix and suffix, then it replaces the original table name for the second run, and it runs it. So if you don't give prefix and suffix, it runs on the original table, and if you give it, it runs on the secondary table. In this way, we were able to customize our framework to run on the original tables, the tables that had either prefix or suffix or both of it. The second customization is the data periods. Here, the data period is nothing but the period on the or the data inside the table that we need to segregate before running. Let's say if I need to run it for a wider period, then I give lesser than equal to or greater than equal to symbols. If I want to run it for a specific month, then I give equal to. Just to shoot out an example, if I want to run the data or the checks on the data that is only for Jan 2024, then I simply give data period equals Jan 2024. If I want to run data that is ranging from 2019 December to 2023 October, then I give greater than 2019 December, greater than or equal to 2019 December, or lesser than or equal to October 2022. In this way, we were able to run the checks on variable data periods by using the corresponding arithmetic operations. The third customization was the database. Since the tables were distributed across different databases, we had to customize our framework to add database as a runtime parameter as well. Finally, the environments had to be customized to run the controls based on different business needs. So we have made test development, pre-production, and production as the optional as the environment options. And all these variables get passed from the Jenkins parameter, as I showed in the screenshot. And these parameters are then passed on to the robot suite as runtime arguments. In this way, we were able to flexibly run for different or a wider business purpose. Again, there are still more, furthermore customizations that we did with the parameters, but I have listed only the key ones. Finally, the results. Robot has its inbuilt result generation feature. So we made use of it, and we generated the results in this format. And when I say format, it gives you all the corresponding steps in the test execution step. So the business can easily read through each of the steps and get to the point where they need. For example, if they want to see the query that's executed, or the database that is executed on, or the result that is generated, or the threshold for which it is validated against, they can loop in through this tree structure and find the corresponding section, which was very good even for debugging purpose and also for the reason of business validation and storing the logs. It has the whole clear information that needs to serve as a test evidence, such that all the evidences are present in the uh, same result, a single result file. Parallelly, when the checks are run and completed, we email the results to business so that uh, they do get notified when each control is run, or each control zone, let's say customer or a container zone 1 is run, and so on. Parallelly, we also store the result in SharePoint for historical for historical viewing purpose. Also, we have an inbuilt error logging section in Robot. It clearly helps us to specify on the right on top of the result HTML log as to what is the exact failure in the log. When I say exact failure, we need not loop through the whole report. Let's say we have a report wherein we have 40-50 plus tables, and if there are subsequent failures, it's difficult to loop through the whole report where we can identify, where we need to go and identify in which step it failed. So in this case, this error logging proved as to be a very good feature. And as you can see, it gives a very clear logging customization, and we customize to report it at a very granular level. Let's say, what is the table name that has failed for? What is the test case it has failed for? What is the column name it is failing for? The total count, the failed record count, the percentage of failure, along with the threshold value. And we classify the failures into two different categories. One, the technical failures. That means the technical IT and the operations team will be intimated for it. So we go and check for whether the code is breaking due to some new functionality, or whether the environment is due to any unstable due to some reason. And for business errors, the emails are sent to the business with the error report, and they will contact either the upstream for a proper data delivery, or they modify the application code, or in some cases, based on the data nature, we need to modify our controls as well. Along with the failing report, we also send them a failing Excel report to give them a sample of the failure. So instead of going into the database to see that particular sample, they can already have, the business can already have the Excel failure reports or the failure samples. And for the production environment alone, we created this feature of creating an incident. So let's assume the sources arrives and the control runs in a much wider fashion. Let's say in any part of the day, or let's say in a weekend evening. It's difficult for someone to sit back and observe the functionality or the controls way of behavior. So the idea is, whenever there's a failure in production, then with the help of the failure log parameter, we just read through the failure, and for each of the failure, we create an incident in the production environment, and corresponding teams are notified as well. When it comes to orchestration, we already saw there were different business layers. So let's assume when our source is directly ingested, in the controls for that particular source, again, it's not at the table level, but at the source level, it runs the controls. Similarly, the same pattern is followed for all the sourcing zones. So once all the sourcing zones and the corresponding controls are done, then a transformation zone jobs trigger. So when a jobs for a particular zone is completed, the corresponding transformation controls also runs in, and that goes on till the last transformation job, and then the data delivery to data mart systems, and then the same application job followed by the controls gets run. And in case of file deliveries, it directly gets delivered from the transformation zone. In this way, we were able to establish a quality gate before exiting any critical business layer that ensures us to deliver the data with correctness, accuracy, and also to serve the purpose of the downstream systems. Wanted to list down a few challenges and solution. One is the data volume. As we grew up, the data volume, as we grew up in the time, the data volume of the tables also grew up, and we have to create more nodes and more spaces to the Hadoop processing units, and also optimize our code on the robot side. Similarly, we had dynamic requirements. That means the YAML files were all flowing in. So we had a proper release management to tackle this. Lastly, the data inconsistency in the test environment while we tested. So in this case, the tests were passing in the lower environment, but it was failing in the higher ones. So we happen to refresh every time a production data is signed off. We mask them and refresh in the lower environment so that we test unit test with accurate data. The future scope of the project, again, is to load the output data into a table and then graphically represent this into a dashboard that gives us a historical performance behavior of the quality checks. Of course, we'll add more functional checks to our future scope as well. From a savings perspective, we came from what happened to be 5 to 7 weeks for a single validation to less than 2 days, which includes application jobs as well. Again, in terms of numbers, we saved close to 5,000 days in 5 years, and we were able to quickly deliver our deliverables as well. As a conclusion, Robot Framework was an amazing tool that has its own inbuilt features and also customizable features. We were able to connect to several database systems and also several tech layers like UI, API, databases, and also the file system validations. The ease of use is much simpler since it is written in much understandable English, and there's a quick support from the RF Robot Framework Foundation forums and Slack places. Finally, we would like to conclude by saying thanks to my company Tata Consultancy Services, who gave me this opportunity to learn and grow. And also, I would like to thank the Robot Framework Foundation for giving me the opportunity to showcase the work me and my team did over the past few years, which might serve as an inspiration for someone who's planning to automate a similar tech stack. Thank you, and I'm open for questions.
Awesome session, Rohit. I see you in the green room. We're about to go live. Let's do this. Hey, welcome to RoboCon. I think you're on mute. Hello, hello, hello. I do not. If you hover the mouse in the bottom middle, there should be an option to select audio. No, I don't even see meters, so. Or maybe try rejoining with a different browser. If you're using Chrome, try Edge.
Can you hear me, Joe?
Yes, perfect. Awesome. Cool. So the first thing I noticed was you showed that diagram of your pipeline. You had all these arrows and all these components. Did that grow organically, or did you plan that? Like, how did you get to that final end result?
When we started, it was just a small component, like a small box, which you saw there, a small old box. But over the time, it just developed into different layers or different databases, and then the different business layers. So when it was starting, it was just a small box. So the idea was to just take a small component and then expand it across.
Very cool. All right, so let's get to some of our other questions here. The first one is, can you share more details on how you're able to categorize the errors automatically on different types, business, technical, and so on? Usually it's hard for me.
Okay, we just read the text of the error message. So usually the business error message starts with something like wherein there is a data level failure, or it says the data has failed due to so-and-so test case and so on. But in case of a technical failure, when a Hadoop is down or something, then we had a separate error logging for that. So based on the text message, the message which we get, we categorize into that, and corresponding teams were notified based on the failures.
Cool. Do you have any tips on how to optimize Robot Framework test execution time for large data sets or queries?
When it comes to large data sets, one thing is to optimize the environment. Let's say Hadoop, we were trying to run it on a larger data sets, and different teams were parallelly using it as well. So the idea was to use queuing system in Hadoop and Hive, and then from a robot perspective, we were segregating the logics separately. Let's say one business layer's logic is separate from another business layer's logic. So in that way, be it reading from your robot file or your Python file, it was much quicker, or be it executing in your environments, it was optimal as well. And parallelly, we did parallel execution as well. That means using the Jenkins feature, like we were parallel able to execute the test. But we were limiting the parallel executions up to a certain number of executions per period. right? Not to exceed that, so that we do not overload the cluster and bring that down. So the idea is to optimally run it and monitor the performance over the time, and then we added more nodes, or we kind of reduced our parallel execution queries as such. So that's it.
So when you're dealing with databases and testing, how do you know you're not doing something destructive, or you have a test that relies on other data that you've manipulated in another test and you run another test expecting the data to be there? Have you ever had those race conditions come up?
Most of our conditions are on predefined data sets that is present in the database. When I say predefined, the data is already present. We do not go there and modify. We just do a read operation on top of the databases. Especially when the higher environments, we have the never risk. We never risk the we never risk the chances of modification, I would say. So the idea is the user is limited just to read the database and do not have write access at all. And in the lower environments, we did have write access to modify our unit test data, but it never gave us a chance to modify the original data. So it was always good in that perspective.
So you did mention Jenkins. They want to know, what challenges did you face, if any, with integrating Robot Framework with Jenkins pipelines, and how did you solve them?
Maybe when the initial stages were there, a connection from the local systems were different from that of Jenkins, but it was more like a one-time setup. And when we were trying to run for a wider use case, let's say we use a single pipeline to run both at the test case level or also at the container level, then it was kind of breaking. So we split that apart. So if you want to run it on a specific test case level for debugging or any purpose, then we can run it at the test case level. Or if you want to run an orchestration using the whole flow, then we run it on a different pipeline. So we split the pipelines as well. So those are the major challenges we faced and how we kind of overcome them.
Cool. What lessons did you learn regarding test data management for this automation across different environments?
Yeah, I expected this question. Yeah, it was tough. It was tough actually, because the way we started, it wasn't test environment, and we just have a single layer like test, and then it was production, I guess. But over the time, and the project matured, there was, and also the layers were building up, and there were different technical and business layers building up. So the idea was to keep data integrity or uniformity across environments. As I said, the idea was to, as I said in the talk, right? The idea was to refresh the data after the each production sign off. So when the data is production signed off, then we refresh them, or we mask them first, and we refresh them in the lower environments. So the consistency of data is met. So we always do on a specific consistent data. So now it's more stable over the past 1.5 years, 2 years. But initially, I agree it was a struggle, and we did take a lot of time to do this masking solution and to refresh the lower environments.
Great. I have time for one last question. Time flies. How do you handle sensitive HIPAA data when it comes to healthcare domain, or do you have to deal with any sensitivity with data in your test?
Yes, we did have sensitive data, and it was a bank as well. So we had to maintain a lot of security regulations. So the idea of the masking solution was to mask especially the sensitive data. So that means a person who's not supposed to view the data, let's say a developer or tester, cannot view the data in the actual production zones. So while we do the masking, we take care that the sensitive data like your name, date of birth, address, and there are lists of like more than 100 elements like that. So we mask all of that by maintaining the data types as well, and the data integrity. That means the spaces, or if there's any special alphanumeric value that's present, we maintain that, but we mask it and give it in a certain way that the original data is not exposed. A similar masking solution to, if you ask me how to do it in healthcare, is to identify the data or the columns that have the critical values, and when you kind of break it to the lower environments, is to mask them with the correct masking solution and get it properly approved with the security team as well, and then we implement.
So thank you so much for contributing to RoboCon this year, Rohit. Any parting words of wisdom you want to leave the RoboCon community?
I would say over the years, I see a lot of automation with respect to Selenium, use a browser or like APIs, but very few interfaces on the database side. I see, at least for the last 6 years, 6+ years, been using for data validation. One of the small part is what I explained today, but there's a larger aspect as well. So I'd encourage users to explore Robot Framework's capability with databases as well. It has a very dynamic nature, so it's very easy and smooth to operate, except for the connections which we struggled initially, and then it is a one-time startup. But then I would highly recommend to use Robot Framework for database level operations, as well as it's turning out to be really good, interesting, and much more flexible as well compared to the other tools.
Yeah, great advice. I couldn't agree more. Thank you so much. And will you be in GatherTown? And if so, which speaker side, the light or the dark side?
The light side.
All right, sounds good. Thanks again, Rohit. Appreciate you. Cheers.
Thank you. Bye.